Join us for 3 days in Orlando, Florida in February 2025 for an event designed to equip IT professionals like you with the tools, knowledge, and strategies to navigate the ever-changing cybersecurity landscape. Secure your spot and register to join us for 3 days of immersive learning, collaboration, and skill building with hands-on hacking labs and much more.
It's good to be reminded of all of the threats that we face and the different ways that we're vulnerable.
You're only as strong as your weakest link, right? You can have all the tools that you want in place, but if you're not taking care of the end user, I think that's the weakest link there.
Network with peers from around the globe, share experiences, and learn from real-world case studies, all aimed at enhancing your capabilities as an IT professional. Register now for Zero Trust World 2025 and take the first step towards a more secure tomorrow.
Just a reminder for those who don't know, if you do attend Zero Trust World and you do take your Cyber Hero test on site and you do pass it, it's not easy. You will get a full refund of your pass as well. So that's the coolest way to do that. So morning, Rob. Morning, Kieran. Thank you for joining us. We're going to talk about network control, and I think, start off by, Rob loves his Microsoft report, don't you?
I love that Microsoft report. It's awesome. It has an entire section on ransomware.
It's called the report, isn't it?
Yeah, no, but it's not a ransomware report. It's their digital whatever defense report, but there's a section on ransomware.
So what's the biggest takeaway from it? One line.
Can I give you 2 lines?
Go on.
92% of attacks, successful attacks, or attacks that lead to ransom, involve leveraging unmanaged devices on the network.
Okay, what was the other one?
70% of encryption happens remotely.
Okay, so what that means is computers are getting more and more secure, which is good. So now attackers are turning their attention to unsecured devices. So this entire webinar is about how you protect your important devices from people who bring unsecured devices onto your network, or maybe devices that you just didn't know exist on your network. Because if you have something you don't know exists, you don't know can manage, and it can connect to your file server, it can connect to your other devices, and it can encrypt them, that's really, really bad news. And I would say that line is probably accurate. Over 70% of ransomware attacks we see do involve remote encryption. So we're going to go through steps beginning to end, how you do this. It's not hard, it's not difficult, and you can make very quick changes, hopefully today. There's no better time. When's the best time to implement security solution? 6 months ago? When's the second best time? Straight after this call. So we're going to go through we're going to start off by going through reasons. We're going to give some demonstrations on examples of what happens when you have properly implemented network control solutions on your network, and what happens when you haven't. And then we're going to go through a example of actually implementing what it looks like beginning to end. So I think you've got a demo to begin with, you, Rob, on an unprotected device being able to see your network without network control.
Yeah, pretty much. Let me just share my screen. Excellent. Just wanted to show what it looks like when an attacker is on a network on an unmanaged device. Now, technically, we have here an unmanaged device and also a managed device. So the VM is unmanaged, the Windows desktop is managed, but right now I've got no network control policies in place. So there's nothing basically controlling network access inbound other than Windows Firewall.
So let's just draw your network. You've got 2 computers on your entire network.
No, and a server. They're looking at a server, they're scanning a server. But when they scan the server, this is what they see. Okay, so this is what a server basically looks like without network control in place. Lots of ports open, including some really interesting ones like 3389, for example. So that is something that they can pivot to. That is something they can target.
The ones that scare me the most are 135, 139, 445. And the reason is 3389 scares me because if they obviously get onto it with the password. Now, someone did make a point to me recently, oh, well, I have dual factor on 3389, and they said, well, we're using, I won't say the tool actually, But they were using a dual factor tool, so you couldn't log in on 3389. And I showed them very easily that you've also got 445 open, 139 and 135 open. So we connected to remote registry. So we connected to RPC services, started remote registry, connected to remote registry, redirected the dual factor codes to another server.
Nice.
Then logged in through 3389. But the other thing that scares me about those 3 ports is you can actually create a GPO directly without even RDPing to push out ransomware to the entire domain. And I don't care how good your backups are if you've got 4,000 devices on Monday morning that are all encrypted.
Not a good day. Not a good day. But yeah, as I said, that's basically what it looks like when you run a scan on a ordinary machine, just running vanilla Windows Firewall. So I have, and I'm going to show my age here, but here's one I prepared earlier. I think I did that before and you slagged me about it. So let me just turn on some of these network control policies. Now, they're pretty self-explanatory. So I've got one to allow DNS. I've got one to permit RDP by object. We'll speak to that, I think, in a little bit more detail in a few minutes. Allowing AD and other ports, allowing file sharing, and this is the important one, which is the default deny. So basically, I'm going to turn on those policies. Now, the AD and other ports policies, this is what I'm saying about, we'll get into it a little bit later. They're using objects. So it's using ThreatLocker objects. So basically, an object is something within ThreatLocker, whether it be a group, an entire organization, or a specific computer. I can be specific or general, but as long as it's running ThreatLocker, we can use those objects. But now those policies have been created. If we do our scan again from both machines, so let me just start my scan on my unmanaged device. So my device not running ThreatLocker, not in one of those groups. And also on my managed device, which is my Windows Desktop 11 here, you'll see the managed device is already finding ports open because I've said that these ports should be open to my managed devices. So it's allowed to do what it needs to do effectively. It's allowed to see what it needs to see, but the same network, another machine on that same network is not going, sorry, I just noticed a question there. We'll come back to it in a second. But basically the ports are going to be visible and available on the managed device, but not on the unmanaged device. Except in this case, DNS, which I've explicitly allowed for all devices because other things need DNS as well.
Okay, so here's our goal here. So you want to come into the network. You want your network, someone plugs into your network or they connect to your Wi-Fi. You don't want
up a VM.
You want people to be able to go out on the internet with their phone. You want people to guests who visit your office to go out and browse the internet, check their email, do whatever they want. However, you don't want them to be able to come in and do a network scan, connect to your Active Directory server, and see your files. So what you've done here is essentially, you don't know what their IP address is going to be because it's all got from DHCP. You've created a policy by DNS.
The DNS is everything. So everything is allowed to connect on DNS, which is what we can see from the scan. But the other ones here are specific. So they're relating to objects within ThreatLocker. So any machine in my workstations group will be allowed to connect on these ports.
Okay. And basically, so someone comes into your network, they do a port scan and they see nothing except DNS, which is exactly how you want it. It's
exactly.
And if someone uninstalls ThreatLocker from their device, it's no longer going to be able to see anything on your network.
Correct.
So let's talk about this at the beginning first, because I want to step back. I'm going to come back into what Rob has referred to as objects as part of a bigger strategy called dynamic ACLs. Firewalls work on ACLs, which essentially allow IPs or IP ranges to connect to a host. And that's all you can get from a firewall. Now, what a dynamic ACL allows you to do is automatically update which IP addresses are allowed to connect based on other information. And there's 3 ways we're going to do that. But before I get into that, I want to start at the very beginning. We've got a lot of ThreatLocker partners and customers on the call here. We've got a lot of people who don't use ThreatLocker. So at the very beginning, what's the first thing we have to do is install an agent. And it's not difficult, and I've done this in 10 minutes at the end of a demo for 5,000 endpoints. So let's just show them how easy. We're not going to do an install because you've already installed it, but let's show them where they go to. It's an MSI. You can push out through SCCM. If you're not using ThreatLocker already, just start a trial and you go into computers. You click install computer on the, but you can pick script RMMs, MSIs, Azure.
Intune.
Intune. Sorry, my brain is just fried. Late flight last night. And Intune, and you've got scripts there. And when you push this out, it takes 2 or 3 minutes and it does nothing to the machine. And if we've got application control, of course, as well, and that's going to be in learning mode. But from a network control, there's no policies in place. So the first thing it starts doing is it starts logging everything in a unified audit. So when you go in here, you can filter by network. And we can see everything. Well, you can show everything.
We can also see all the stuff being blocked that Nmap was trying to do a second ago.
We can see everything in the unified audit. We can see every call, every port. Now, there's a feature you can turn on here. So you'll notice for outbound, because it's also going to log outbound traffic. On the bottom there, you'll notice it says Dropbox, because this is outbound and it's connecting to Dropbox. This is a feature called domain name parsing. And this is really useful because when we start thinking about outbound traffic, it allows you to create rules based on the destination domain name as well. Now, I want to show you how to turn that on, but I also want to give you a little bit of a caveat with it. It has caused problems with certain very old applications that don't format their headers correctly. If you have a problem with something going slow when you turn on domain name parsing, turn it off, log the issue, and we'll get to the bottom of the issue. We've made exclusions for domain name parsing for about 30 apps that were made in 1997 at this point. So, and we can solve the problem. But can we just show somebody how to turn domain name parsing on and off, if you don't mind? So,
yeah. So basically, you can do it from your organizations page. If you go to settings and you go to options, so it's an option called enable driver domain name parsing. And so you literally just type it in there. It's already typed in, so I can't add it again, but that's basically how you do it. And then you just restart the agents from the computers page.
You can also do it from the computers page on the option. So if you want to test some old applications to make sure it doesn't cause you any issues, go into the computers page.
Do it at various levels. So you can do it from the computers page as well. So I could do it for an individual computer, or you can do it for groups as well. So I could do it, say, for my workstations group, for example. I've got options here too.
Now, we know of no issues with no applications at the moment, but I always say if you're running really legacy applications, because basically what we do is we read the header. If the header isn't formatted correctly, sometimes it can cause the application to go slow. Every time we get notice, we fix it, we understand the application, we change the way we read the header, and everything's solved. And we know of no outstanding issues right now, but that doesn't, on the current build of ThreatLocker, is the most patched feature for old applications. So if you do have old applications, just run it on a few computers or a few groups. If you're running standard applications, it shouldn't cause any problems. That will now give you the host names, which means you can see as an IT admin all of the users, what websites they're going to. If they're remote, you can see, what they're doing on the internet from one central location within a couple of minutes of them doing it. So we've got a log here. I like to do it another way first. I like to go and create policies before we have a log. So it's pretty simple. Workstations in 99% of cases need no ports open, except maybe if you're just using regular Windows Update services. There's a port called what's it called? Windows
Update Delivery Optimization 7680.
And you can add that from community, can you, Rob?
You can add that from community. So community, network policy, Windows Update Delivery Optimization. You're probably going to want to turn that on because it's really noisy otherwise.
It's noisy. Now, if you don't turn it on, it doesn't break Windows Update. But what this does,
it just means that Windows Update needs to go out to the internet for every single update,
as opposed to the computer sitting next to it. So this is a nice port on the workstations you can add. Outside of that, we pretty much just want to add a default deny policy.
One exception to that, screen mirroring. I discovered this when trying to do screen mirror one day. So there is a screen mirroring port 7236, which it needs to get back from whatever it's mirroring to. Just by the by, but yeah, screen mirroring is something else that workstations will sometimes need to do.
Now what's nice about this is if you start off and you create no policy whatsoever. So if you say on your workstations, I don't think I need any policy, you can go into the unified audit, and if you don't mind just showing this, and you can say, I want to know, and then you can say simulate denies. And it will show you everything that would have been denied because we have no policy. And it will show them as a green deny. Now, what we're actually doing here is we're taking the Windows firewall default action. So we're not going to interfere with your firewall. If you create a policy to allow or deny something, then we'll interfere with your firewall. But at this point, if we're not sure what we need, we can go into here and we can see everything that's happening. We can see 135, 389, 445, and they're obviously on the server. So, but from a workstation's point of view, most of the time, we just don't need to do anything. We can simulate denies, double check. We can create the Windows policy. I wouldn't even create the screen mirroring because it makes me nervous that someone would mirror their screen unless they use that feature, but you'll see it in your simulated denies.
And if there's particular locations that you don't want people to be able to go to, you can also create outbound network control policies. So blocking the likes of Mega or Dropbox or any of
What's Mega?
those. Mega is, do you remember Kim.com?
No.
It's notorious. I don't know if you call him a cyber criminal, but basically he set up a file sharing thing called Mega where all the dodgy stuff is uploaded to. It's often used by ransomware gangs.
Okay, so that's a good idea to block that then. So outbound you can block as well. You can block Facebook, you can block Dropbox. That's a nice feature of domain name parsing. But for workstations, you do a simulation, check there's nothing you wouldn't expect, maybe create the Windows Update optimization, and then just turn on the default deny policy.
I tend to do the Windows Update delivery optimization for the entire organization as opposed to just for workstations.
That's not bad.
It does on servers as well. So,
okay, so this is 10 minutes work. And by the way, if you have a ThreatLocker solution engineer, well, you do if you're a ThreatLocker partner or on trial or customer, jump on a call and they will walk you through this as well. Step 2 is your servers. A little bit more complicated, not massively more complicated. Let's think about what we have on a server. We have Active Directory ports, we have RDP, you have file sharing, you have DNS on most servers. Now, if you have a web server, you can go and add those policies as well. Same scenario. You can use ThreatLocker Community to pull these down. So if you go into Community, you can search for, say, Active Directory or Directory as Robin.
okay, so we'll go permit Active Directory ports inbound. You decide where you want to permit it. So it'll default to entire organization. So you might say, in my case, I've only got one server in my servers group. But if you've got a bunch of servers in the servers group, you might say, I want to do it specifically for my AD server. But we'll just do it for the servers group for the purposes of the exercise. Directions already set. The source, this bit is important. So back to Danny's mentioning of dynamic ACLs and objects. So right now, if I just go ahead and allow this, it's going to open that port to anything and everything, which is not what we want. So I'm going to be specific and I'm going to say, for example, I only want machines in my organization to be able to connect to these ports. The ports are already set here. So I literally just click on download and I now have a shiny new policy to permit Active Directory ports inbound on my servers group.
And then we can do the same, repeat the same for DNS and file shares if you have file shares and DNS.
Correct. So we'll do file shares here. Okay, so permit file shares. So again, just going to apply to my servers group. Same thing again. I'm going to select my source and I'm going to make it my organization. So machines, again, within my organization are going to be allowed to connect on these ports. We'll mention sometimes these ports will need to be tweaked, or these rules will need to be tweaked. So as an example, I notice in the permit Active Directory ports, we have a entry here for 53, which is DNS. As you mentioned earlier on, you probably want to allow DNS from devices other than protected devices. So let's just create a new policy manually.
We don't have DNS in the community now.
I don't think we have it separately, but if not, we can arrange it. So again, source, this time the source is going to be everything. And the port in this case is going to be DNS, which is port 53. So just allow everything to connect on port 53.
Okay.
That's pretty much everything we're going to need along with the default deny.
Now, what you could do as well is add RDP in there. Now, what's interesting, you could pick just the IT person's computer for RDP. So, and again, we can do it from community or we could do it just from here.
Okay. So source, this time the object is going to be very specifically Rob's desktop. Allow that. Done.
Okay, so what we have now is all of our permit policies. We've put no deny policy in place. So what this means is it's going to do exactly what Windows wants to do. It's going to allow these, but if it doesn't hit one of these policies, it will revert to whatever your current Windows firewall rule is. This allows us to now go into the unified audit a week later, do a simulation, see if we've got a bunch of noise, and if we don't have noise, If we have noise, we can say, okay, we've already added an exception to this. If we don't have noise, great. And there may be just noise that you actually want to block. You may see things that you didn't know were on your network that are talking to your file server. So we check the noise and then we turn it into lockdown mode.
So lockdown mode is basically just creating a default deny policy. So direction inbound, source everything, deny. Obviously, you need to be really careful with this, that the default deny needs to be at the very bottom, which I did not create there because order is important.
And when you're actually creating it, it gives you the option to say at the bottom.
It does, yes. So that's pretty much what I had there before, where we've just created it in, what, 2-3 minutes?
Now, I did have a question here. So somebody asked, can we do this based on network groups? And there's two parts to security. There's the networking, there's outbound and there's inbound. So on inbound, you do not know a user when you're opening a port because there's no such TCP IP doesn't allow us to see a user. It only allows us to see an IP address, which we tie back to a device. So of course we can map them to computer groups in Active Directory by making sure we deploy ThreatLocker into the correct group based on an organizational unit, but we can't base it on user. But we can do it on the outbound on the basis that we've only allowed ThreatLocker to have DNS, for example, RDP for Rob's computer. We could change that and say, I want to allow RDP for the entire organization, and then we could create a ring fencing policy for RDP that only applies to Rob's user, and that means if he opens anyone else opens RDP, because we know that the device is running ThreatLocker and protected, we could say only allow Rob to run RDP for outbound traffic to this server, and then everyone else who runs RDP can't outbound to the server on the ring fencing policy. So that's how you would achieve the outbound based on username, but with the network control, with the firewall rules, that's where we're creating it on IP addresses or objects. So now I've created this, we've looked at the audit, dynamic ACLs. I want to talk about that because we're talking about objects a lot. I want to talk about how objects actually work. And Kieran has very kindly written a white paper on this, and it's been rejected 15 times, and it's eventually at a stage where we're willing to let it go out. But objects, and we'll share this white paper after the webinar as well. Objects basically allow you to automatically determine if an item can access your device based on something other than the IP address, or dynamic ACLs. And most of the time we use objects. And the way an object works is you create a policy for Rob's PC, and ThreatLocker magically knows this is Rob's PC IP address. The way it actually knows is when Rob's PC tries to connect to the server, it basically says to the server, I'm trying to connect to RDP, for example. The server then connects back to Rob's PC, and the way we configure this, how can we configure how it connects back? It's in network control.
Oh, yeah, network control
settings. So it uses a network control challenge. So it will automatically connect back to Rob's PC before it even responds if the port's open or not, and say, hey, you're trying to connect to me. It's going to exchange a shard string, and it's going to tell it to basically share its objects with a string and return it back to the server. And if the objects match, we're not having to send the actual data over the link. So if someone's sniffing, it won't do them any good. If the objects match, it's going to say, oh, I'm opening this port, and I will reply with true. And this is where this works really well on a LAN, because you're immediately connecting to your server. It can immediately connect back before it responds, and then it caches that data for a few minutes, so it's not slowing down future connections. That's the first way that objects work. The second way they work is if it can't connect back to Rob's machine, it will actually go off the ThreatLocker's cloud and say, I've got an unprotected device here I'm about to deny. Do you know who this IP address is? Now, everyone in machines is checking in every minute, and every time they change their IP address, they tell ThreatLocker, hey, I just changed my IP address. So ThreatLocker's cloud will say, you're coming back and you're seeing 192.168.202.3. And it'll go, I know this. This is Rob's, on the same network as you. This is Rob's computer. So it will say, this is Rob's computer. It's fine. And what's really cool, if you go into the unified audit there, I don't know if it's on beta or on portal, because we made some changes here. We'll find out now. If you just click on any of those rules, you can actually click on an IP address. There you go. It's on portal. And it will show you who that IP address belongs to in the ThreatLocker audit, if we know who it belongs to at that time. So there's two ways it can do it. It can do it from challenging back or querying ThreatLocker Cloud. It always tries a challenge first because it's quicker if it's on the local network. We can also do this for remote servers. And I want to talk about RDP specifically. because nobody should have RDP open on the internet. But let's say you do want to publish remote desktops to people. You can use RD Gateway, you can use a Citrix Gateway, you can use various different tools like that, often over HTTP, and they should always have dual factor authentication on them. But those devices are still susceptible to vulnerabilities. So we can also use objects over the internet. So when you connect to, let's just say for argument's sake, you opened RD Web and we want to create a policy. So if we don't mind going into network control, and let's create a policy for web traffic on your servers there. And we're going to allow web traffic from only trusted devices. And we'll say inbound, selected sources. And we're going to say just our organization. I mean, we probably should always be more specific than the entire organization, but we'll say anyone in our org can access this. And we'll open up port 443. Well, I wasn't going to publish it on 80, but
you never know.
Just in case you want to send your RD traffic unencrypted over the internet. So we're going to open this web server up, and this is our RD gateway. So when we create this policy and you open your external firewall to this, assuming it's not in the cloud, it does have an external firewall, nobody will be able to see that port is open publicly. But if Rob's computer tries to connect to it, it will say, I know this is Rob's computer because I'm going to connect back to ThreatLocker. ThreatLocker is going to tell me this IP address, this 50.8.5.3 public IP address, is currently the same IP address Rob's on. So I'm going to open that port up automatically. What this means is you're not opening ports to the entire world. You're only opening ports to the public IP addresses of your computer. So just to recap, connect back to the client on a local network. If it can't connect back to the client, it goes to ThreatLocker Cloud, and we will tell it. On a public network, it will go to ThreatLocker Cloud and say, hey, who's running this public IP address? And it will say these devices are on this public IP address, and it will automatically open it. It means you've got less ports open to the internet. Now, I cannot stress this enough. It's still the biggest cause of ransomware, having RDP open. It's getting smaller, which is good news, but it is probably the single biggest. It probably represents 30 to 40% of ransomware cases, major ransomware cases. Someone had RDP open on the internet. So by putting these policies in place like this, even if you accidentally opened RDP on your external firewall, no one will be able to see that. But I want to talk about firefighting here, because we are the beginning of December and we see more cyber attacks at this time of year than any other time of year. We need to stop this really fast. And the problem is with deploying network control is it's going to take you a couple of weeks to do a simulation and make sure you don't block something you don't want. Not in time, but in linear time. So you spend a few hours. But there's a couple of policies you should probably put in place right away now that will have less impact, more impact from a security point of view, and less impact from a user point of view. And maybe you want to explain these policies, Rob.
Yeah, it's not unlike a rather tremendous video that a handsome young man did for the homepage of the portal recently around SMB. It's the same principle. So instead of having to set up default denies and worry about all the other ports that you have to worry about, we're just going to focus or concentrate on port 3389. So we have a couple of policies here. We've got a deny RDP policy in the community, again, under network policy. So I'm just going to download that to my servers group. And then we've also got a permit policy. So the permit policy is basically a permit, but we mention here that it should use objects to limit access. So basically, if we go to our source and we select our object, I'm going to use Rob's demo desktop for argument's sake, and I'm going to download that policy to our servers group. So there's the two policies. Created a explicit permit for Rob's machine and a default deny for everything else. So that's a really easy way to lock down RDP. As I said, you can do the same for file sharing. You do the same for pretty much anything, but if you don't want to get into all the, complications, shall we say, of, other ports and other things that are going on your network, at least lock down RDP.
Okay, so one of them asked, is the functionality lost if there's an internet outage? If there's an internet outage, we obviously can't talk to ThreatLocker Cloud, but we will still connect back to the network challenge. So if you're on the LAN, if you have no internet, it's going to be irrelevant anyway. So if you're on the LAN, you'll still be able to connect to the server perfectly. So that's very easy to do. Are any of these options pre-enabled, or is it a good list of what each option does?
I've just replied to that, which is basically just search for the word options in the kb.threatlocker.com.
Somebody brought up domain name parsing. I just bring this up at the end. It doesn't block things. It's just hanging the network connection because we can't parse the header. The latest build of ThreatLocker fixes all known issues of domain name parsing. There may be unknown. It is a headache, and it's been the worst feature we ever implemented, but it's also the only effective way you can get a host name from a thing. So if you do have some apps that stop working when you turn it on, we always say test domain name parsing if you've got older apps. It's not blocking the apps, it's just hanging up because it's waiting for that network connection. Like I said, the latest build that's publicly available fixes everything we've known. But if it doesn't, come on, we'll run a network scan and then they can fix it. So please, do that. And don't put it on a major live system that's critical and be ready to turn it off.
Hunter, does ThreatLocker plan on creating a malicious destination built-ins or potentially network destination built-ins for website groups, cloud source sites, social media sites, etc.? This way you could create policy to prevent users from going to specific types of sites without having to keep the policy up to date.
Well, so the ThreatLocker detect will automatically detect malicious known sites. But to answer things like social media sites, I think we have some dictionaries, do we, or not?
We've got some built-ins, yes. So if we create a block stuff policy, an outbound policy, and the destination can be a tag of which we've got quite a few defaults created already.
So we don't have things like adult sites and weapon sites and things like that.
I don't believe so.
So to answer your question, we are doing research on this. We have what we call a spike as to the viability of turning this into, it's not a web filtering solution. It can block websites, but the viability of bringing those lists in, and is it in demand with what we really want to do? So we don't know for certain, but we are doing various tests, and we will be launching any new products at Zero Trust World. So check out Zero Trust World for more answers on that.
With the
Alex? Oh, sorry, go ahead, Kieran.
the cloud storage sites and social media sites, we do have a community policy for those that you can check out.
Okay, thank you, Kieran.
Alex has asked, how would you manage non-domain joined machines when deploying new PCs?
Same way, it doesn't matter if it's domain joined or not domain joined. You can still put it on ThreatLocker. You can still put it in there. You can also add exceptions by IP addresses. So if you say, hey, my scanner needs to access my SMB share, you can add your IP address that you're scanning. You don't just have to add the object in it. And you'll see that when you do your simulation. So you just go into your policy and say, I want to add it. Somebody asked, would DHCP be a required port? DHCP is not a port in that it's established before the network connection is made. So DHCP would not be a required port. It's a lower level. So that's answered.
Can ThreatLocker network control run with another active endpoint firewall?
So here's the problem. Yes, it can. And the way firewalls work is they work in order. The risk becomes two things. One is depends on where we run. If we are the last person in the stack, so if in the Windows firewall, we go after the Windows firewall. So what happens is Windows runs its rules, sends it to us, and then we can either change the decision of the Windows rule, or we can just return continue as is. And when you have no policies in place, we return continue as is. So say you put deny RDP and allow RDP like we just did, we would say to Windows deny RDP or allow RDP, and then if it wasn't RDP, would say continue as is. If it's another third-party firewall, we don't know whether they run before or after us. You may have to then configure two firewalls to achieve the same thing. Normally, if we're last in the stack, we're just going to change the result to what we want it to be, and the same could happen with somebody else. So it's a bit more complicated than yes or no, and quite often depends on the other company. On the other.
I'm going to take this one. I have an inbound RDP blocked on our WAN edge firewall. Do you think it's a good idea to implement that with ThreatLocker as well? Absolutely. 100%.
Two reasons. One is your WAN firewall may get misconfigured in the future, but two is, what about if someone gets a reverse shell onto one of your users' computers and they now hop to your server?
Or
It's
somebody brings a machine in from home, or somebody spins up a VM on a Hyper-V server and uses that for malicious intent. Yes, basically, you should absolutely do it. Just a very quick, by the by, I went through this exercise with a customer in Europe about a year ago now. And we set this up and we just left it in monitor only mode. We weren't blocking anything and came back about a week later. And I said to him, how many of it was a group of servers, I think about 60 or 70 servers he had in a data center. It was like his own private cloud. I said to him, how many of these servers do you think have had incoming RDP connections? And he said, with absolute certainty, two. There should be two servers that have had incoming RDP connections. When we went through the audit, we literally just searched for port 3389. There was 17. He'd misconfigured the firewall. So it can and does happen. So absolutely you should do this irrespective of whatever you think your firewall is set up as.
okay. So there's another thing. Before we go to another question, I want to point out another point that's really cool about ThreatLocker when you're using ThreatLocker's detect, which is our EDR, with RDP or with network control. And maybe we can do a quick demo on this. You can actually set up. Have you got a community policy that says high number of invalid logins?
I don't think it's a community policy. I think it's a
Okay,
master policy, if I'm not much mistaken.
It's in there by default. I thought they were all in community. It's probably just type login.
Yeah.
Probably should be in there if it's not in community, because I know it's a master policy. Login account disable. Incorrect username and password. Incorrect username and password. So do you want to open that one there? Actually, so do two things. Open a new tab before we do that and just create a new network policy called disable RDP. You can actually set triggers that if X happens, then I want to turn on a policy. So we could set a network policy saying disable RDP, and we can set it at the org level, and we're going to disable it. So let's say selected ports as RDP. Let's set deny. And let's set this to disabled. So basically, we've got a policy here that completely blocks RDP that is disabled. What we can do using detect, you can use any products combined on this. We could say if that, so we've got a policy here. So if we click, scroll down on that, and we're going to make some modifications for it. So we've basically said, hey, we can use it at 5. It's a 5. So we've said if the event log ID matches 4625 and it's Windows security and it matches security in the event log name and there's 5 occurrences of it within 3 minutes, it means someone's trying to DDoS my RDP server. So in this case, I'm going to change it to automatically enable this policy. So what we can do is we've got an action saying create an alert, but we can also add a second action that's called enable network policy. And you could say disable RDP. And what this will do is on that one machine, it will turn off RDP access. And it will also, so the user will no longer be able to try to log in on RDP. And it will also create an alert. And when you clear the alert, it will re-enable it. Or you can go and create a permanent policy. This is a nice little way of saying, okay, I'm going to allow RDP for the IT guy's computer, but if he puts his password in wrong 100 times, it's going to be disabled until someone's responded to the alert. So when you're using detect, you can do a handful of things like this. You can also say things like, hey, if this happens, if this policy gets hit, if RDP gets hit, I want to automatically disable PowerShell on the machine through app control. So we're not going to go into detail on that, but there's a lot of different options and configurations and if then, else then you can do to harden your environment if these things do happen. So we got a few minutes. So do we want to pick some questions, Rob? I know you want to get through all of them. Promo code for Sword, that will be in the chat. So that one's done. Go ahead.
Chris, would you create a deny for inbound and outbound if you know what should be coming in and out? We actually discussed this recently, and the answer is basically yes. So, like, does your server need to connect out, or your servers need to connect outbound to the entire internet? Realistically, probably not.
SolarWinds, Orion, Exchange, both examples of vulnerabilities that couldn't be exploited when they couldn't reach out to the internet. So servers shouldn't be able to go out to the internet at all. It stops people browsing the web on them. It's a really good practice. Workstations should technically only go out on 443 and 338. 443 and 80. Although there's a lot of websites that still use ports that aren't those two. So you can do a simulation if it's causing you a problem.
Pierre, what about managing a web server? How can we protect that server with network control when there is non-ThreatLocker devices connected on port 443? The short answer is you just create a rule saying permit traffic on port 443. It doesn't have to be tied to an object. It can be just allow this port if that's what's needed.
We do it on 3 million endpoints connecting to servers at any point in time in ThreatLocker.
Correct.
So you can open to the whole world. It's open the world when you need to.
Yeah, and again, we do have, so you can do IP addresses, and this was another question that was asked. You can do ranges here if you want as well. You can do IPv6 if you're a bit like that. You can use keywords, tags, and objects. So you've got a number of different options here in terms of your source IP address.
I'm going to talk about keywords very quickly, actually. That's
all.
I'll talk about keywords really. It's going to be in the document, but keywords are a really good way of pre-authenticating when you're not in the same ThreatLocker organization. So we talked about network challenge and network objects and the way that they work, but you can also do a third mechanism, which is a keyword. So basically you generate a random string and on a policy. So you say this policy says anyone who's pre-authenticated with this keyword, Rob is the best. Essentially it's a pre-shared key. And I think I
can't believe I actually got you to read that out, Danny.
Yeah. So only you would have Rob is the best as your password. We're going to say if they pre-authenticate with this, then they can use 443. And what will happen is we can now go to any ThreatLocker tenant. And technically, you don't need to be a ThreatLocker tenant. I've seen people script this in their website where somebody requests a support request and it calls a REST API. But it can now call the REST API on the ThreatLocker, the server itself, and say, hey, here's my keyword, open up my IP address. And as long as it's pre-authenticated with that pre-shared key, it will open it up for 5 minutes. And if you want to configure it from the client side, you can literally just go into network control. You can go into auth hosts in the top right corner. And you can say, I want to create a new auth host. And you can say, here's my destination server. And yes, it's HTTP because there's no SSL cert on the service, but we only send handshake data. So we'd say, Rob's RD gateway server or web server is web server 1. And I'm not saying that again, Rob. And then you type the keyword in, and basically this will say every machine in the organization will every 55 seconds will tell ThreatLocker that here's my keyword. And if you've got any policies, use this keyword. So the client has to know it and the server has to know it. And you can also do it from like APIs if you've got third-party apps. So this is great when you're outside of the organization. It's a little bit more complicated to set up. The one consideration with this is if you've got 10,000 computers in your organization, that means those 10,000 computers are going to authenticate against that server every minute, regardless to whether they need to connect to the server or not. So it's really only for the exception, and you should use objects first. But it is really good, and I have seen people do it with remote support requests and REST APIs as well.
George, can we create a policy to allow servers to only reach out to data or Windows updates and TL for internet inbound? Yeah, I presume that's, sorry, internet bound, so outbound. Yes, is the short answer, George, and that's a really good idea.
Peter Donnelly's asked, how can you get started defining users and servers? Oh, that just disappeared. As group objects so they can create relationships between the users and the groups. So the first thing is we need to create the object relationship. So are these objects allowed to connect to the port? And then the second thing is we need to create ring fencing policies for the applications to limit it by users. What I would suggest, that's a bit more complicated than I can answer in 30 seconds, is if you just jump on with your engineer and say, look, I want to allow this user to access this port. First, we set the company objects, and then we set the user in the ring fencing policy based on how they do it. I'm
pretty sure Peter's engineer is you, Danny. You just volunteered a job for yourself.
Fun.
Tom, is there any additional training or documentation on Endpoint Firewall in the portal?
There's a whole TLU if you go to ThreatLocker University, and there's more pages than I care to read on it. But yes, there is that. We also do run our boot camps on TLU, and the white paper will be emailed around dynamic ACLs today as well. Can you allow SSL VPN hosts since they all have private IP addresses other than on LAN IP addresses? It doesn't really matter where the IP address is. If it's been assigned an IP address, we can allow it. The question is on the VPN sometimes is, does the challenge work where it can connect back to the device because the VPN might block the reverse traffic. So you have to add that exception, which is default to 8811 or 8011.
8811.
8811. So you have to allow that. Otherwise, it relies on ThreatLocker going to the cloud. Now, the challenge with the cloud is you might get that 30-second delay or something before it knows your IP address. But you can allow VPNs. If someone connects to the VPN, it's a private address. It's better if you allow that reverse traffic on the VPN, so it doesn't have to go to the cloud. But if not, it'll cause a 30-second delay. I'll finish out with one thing, and this has been delayed and delayed and delayed and delayed, and we're getting really close. And the reason it's been delayed is because of Apple. We also have the ThreatLocker Access app being released for your phones. And what that does is that allows you to track the IP addresses of your phones, so you can automatically update the ACL based on your phone being able to connect to a device as well. This doesn't seem important necessarily because your phone's probably not connecting to your Active Directory server, but it is effectively going to update the Office 365 ACL. So you can set the same conditional access policy or default deny policy to say only these devices can access my Office 365 tenant, and then it will track your phones and your laptops and update the ACL for the IP address. It's been delayed over and over again. It's not because of us. It's because Apple don't like the fact that the app uses various different sensors on the phone to determine where you are, your IP address. We have to track your motion as well, because if we don't track motion and Wi-Fi connect,
we don't know if you're grooving or not.
We don't know if you're moving locations. Otherwise, we just eat the battery because we're constantly running through a loop. So Apple's giving us a whole bunch of pain points as to why should we have this in the Apple Store, hence the delay. So that's why that one hasn't come out. I'm going
to choose to ignore the fact that you said something bad about Apple there.
I never said anything bad about Apple. We're pretty much out of time, but again, please guys, even if you can't get this deployed, go to your engineer, see what you can do, at least put the RDP or the remote SMB policies in place. The amount of remote encryption we're seeing is making me feel sick. If you aren't using ThreatLocker and you'd like to do a demo, Spencer's going to drop a demo link into the webinar now, into the chat now. If you are using ThreatLocker and you don't use our network control, or you don't use our EDR, you don't use our MDR, just ask your engineer for a free trial of it. Ask your account manager for a free trial of it. You can get a free trial. And, it's a great time to do a free trial of the MDR, because what you do not want is to come back from the Christmas holidays or whatever time you're taking off and to find your device is encrypted. It's not a nice feeling. It's very, very difficult to recover with. And every time we see a customer hit by ransomware because they're in monitor only mode or they didn't turn on the things, it makes me feel sick. And I hope at the very least we get those RDP and remote encryptions in place. And if you want to time them, you want to just put them on when you go home at the weekend, at least it gives you some protection that is otherwise not there. But it is really effective, and please put them in place. There is a video on the login screen on how to do the temporary policies for remote encryption, and we're going to keep updating those videos on the login screen with weekly tips. So we've got the link for a demo in the chat. We've got the ztw.com if you want to get ZTW tickets, and there's a coupon in the chat and for $200 off. And guys, thank you very much for your time today. Thank you, Rob. Thank you, Kieran.
Thank you, Danny. Thank you, Kieran.
Thank you, Spencer.
Thank you.
Okay.
Bye,
Enjoy.
everyone.
Bye-bye.